Exam question revision video for GCSE reverse probability. So the question: a bag contains 200 beads, some of them are red. We take a bead at random, record its colour, and then we put the bead back, so it's replaced. A second bead is selected at random and its colour is also recorded. The probability that 2 red beads are selected is 0.1369. Calculate the number of red beads in the bag. Okay, so what are we thinking here? Well, first of all, we remember that for any event, the probability of the event is the number of equally likely successful outcomes divided by the number of equally likely possible outcomes. So, if we want to find the number of red beads, we can work backwards from thinking about the probability that the probability of getting a red bead is the number of red beads over the total number of beads. So, this means if we rearrange that by timesing both sides by the total number of beads, we get that the number of red beads is equal to the probability of getting a red times the total number of beads. Now, we also need to note that this is a 2 event situation. We're taking 2 beads, but because the first bead is replaced, the probability of selecting a red bead is the same for each event. The events are independent. That means that neither of them depends on the other. Whatever we take the first time doesn't change the probability of what we take the second time, so the events are independent. That means to find the final probability, we just multiply the 2 individual probabilities. And if we call the probability of selecting a red bead P, then the probability of selecting red followed by red will be P times P, or P squared. Now that's what we've been given, so we can say that P squared is equal to 0.1369. That means that P must be the square root of 0.1369, and if we do that on the calculator we get 0.37. Now the number of red beads must be that probability times the total number, which was the third line down in our thinking. The number of red beads is the probability of a red, 0.37, times the total number of beads, 200, and we do that and we get 74. Okay, there is an alternative way of looking at this, and this time the thinking goes like this. If we call the number of red beads n and the probability of selecting a red bead p, then that means that P will be n over 200. So n is the number of successes and 200 is the number of possibles. And this situation is still a 2 event situation, of course, but because the first bead is replaced, the probability of selecting a red bead is the same for each event. The events are independent, so to find the final probability we multiply the 2 individual ones, and that means we have P times P is 0.1369 as we saw before, but this time because we've noted that P is n over 200, we can go straight for saying that n over 200 times n over 200, which is the same as P times P, that must equal 0.1369. And we also note that we can write n over 200 times n over 200 as n over 200 squared, because it's something times by itself. So we get n over 200 squared is equal to 0.1369. Again, we have to square root, so we just get n over 200, which therefore equals 0.37, and now we times both sides by 200, which gives n is 200 times 0.37, because the 200 that was dividing into n has been cancelled out by multiplying by 200, and that means that n is 74, which of course is the same as what we got before, which it must be. Now for the bonus material in this video, we're going to look at a situation that's similar to that, but it's called without replacement. So this time we've got a bag with 25 sweets in, and some of them are red. Hugh takes a sweet at random and eats it, and Mary then takes a sweet and eats it. The probability that 2 red sweets are eaten is 0.15. Calculate the number of red sweets now in the bag. This time, this is our thinking of course, this time the probabilities will change because the first sweet taken is not replaced in the bag because Hugh eats it. So what that means is, if the number of red sweets is n, then the first probability, so the probability that Hugh takes a red sweet, is going to be n over 25. But for the second probability, we've got one less red sweet, so that's n minus 1, and we've got one less sweets altogether, or one fewer, I should say. Not that we mind nowadays. So we get, for the probability of Mary's sweet being red, we get n minus 1 over 25 minus 1. Now these events are independent because once we've done the first one, we've accounted for the fact that the second probability is related by working out what it is separately. So in this situation we can multiply these probabilities together, and that will give us the probability we've been given that 2 red sweets are eaten. Okay. So we now have our n over 25 times n minus 1 over 24, because obviously 25 taken over 1 is 24, and as we've seen, by multiplying those together we get our 0.15. Now what we do is we times both sides by 25 and by 24. That means on the left hand side those 25 and 24 that were dividing have been now cancelled out. And on the right hand side we've got 25 times 24 times 0.15, and if we put that in the calculator, or do it in your head if you can, but I would suggest using the calculator, you get 90. So n times n minus 1 is 90, and we could turn that into a quadratic equation. So n times n minus 1 gives us n squared minus n, and then we subtract 90 from both sides, so we get minus 90, and then on the right hand side we've subtracted the 90, so that's 0. Now to work out what the values are that go in the two brackets for this quadratic, we need them to multiply to 90, so we can pop down all the possibilities there. So we've got 1 times 90 or 2 times 45 and so on. Now because we've got minus n in the middle, we know that the bigger number must be negative. And in fact we need the numbers to add up to minus 1, because we've got minus 1 times n, and that would be 9 and minus 10. So that means we've got brackets n plus 9 and n minus 10 that multiply to give us 0, and we know the value of n must be positive because there are a positive number of sweets, or positive number of red sweets in fact, in the bag, and the positive solution to that is n equals 10. Now I would just note as well that we could have solved this rather than making a quadratic. We could have thought we've got two numbers next to each other, n and n minus 1 are consecutive numbers, so what two numbers next to each other multiply to 90, and we might well be able to think of 10 times 9, which would have straight away given us n equals 10. But the quadratic method is a backup if you couldn't think of that. And we have got one final thing to do, because we've been asked to calculate the number of red sweets now in the bag. So this is after Hugh and Mary have taken their sweets. So there were 10, they've eaten 2 of them, so that leaves us with 8, which is the final answer.